Welcome to Spring LIB.
Hi, this problem is a continuation of previous problem, so I'll just recap the previous problem quickly. So in the previous problem, we were given 3 points A, B, and C on a disk which was moving on a plane, and we were not given all the velocity components, but only certain velocity components. So B, for example, was minus 7.4 meters per second in X, and we didn't know the Y component. For C, we knew that it's minus 1.4 in X direction, but we didn't know the Y component. And for A, we didn't know the X component, but we knew the Y component was minus 7. So it was like this. Okay, so then we solved this problem by, as usual, by breaking the problem into translation plus rotation. Translational velocity is same for all the points. That's the most important point to remember. So we draw our disk again, and we give each point a translational velocity Vt. Same magnitude, same direction. Now rotational velocity is omega cross r, so we need to assume an omega. We assumed that omega was like this, going into the page. So if it's going into the page and a circle is rotating like this, then you can imagine that the radial velocities, they are always tangential, and this direction can be figured out by just assuming a particular direction of rotation. So if the direction of rotation is like this, you can easily see that all these omega r, the radial velocities will be pointing like this. Or you can do a cross product by taking your right hand, pointing your fingers towards, 4 fingers towards inside the page, that is vector A, omega, and then curl your right hand fingers towards vector B, which is R. So let's say this point, R is along this, and then your thumb, when you point it out, it will point along this direction, which is omega R. So you can do this as well, but I think it's very intuitive once you figure out the rotation direction. Okay. Then what we did is we broke down the components. We added Vt and omega r in terms of vector, of course, because these are vector quantities. And then we equated the known components. So we equated Vbx, Vcx, and Vay, and we solved these components to figure out Vtx was minus 1.4 meters per second, Vty was minus 1 meters per second, and omega r was minus 6 meters per second. So we know these quantities. So this is known. So now let us solve this problem. So in this problem, the first question is, what is the velocity of point origin? So at origin, r is 0 because this is the origin of our coordinate system. So then VO is just going to be Vt, which will be minus 1.4 meters per second I minus 1 meters per second J. So this is our Vt, which is our VO simply. Now, at what point velocity is 0? This is asked. So we need to give the radius coordinate or the position coordinates of the point where the net velocity is 0. So for net velocity, as we always say that translational and rotational velocity, which is omega cross r, this should be 0, which means that this omega cross r should be equal to minus Vt. So omega, we assume that this was along minus k direction. Remember that. So let us write down. Let us assume our r to be some xi plus yj, x naught I plus y naught j. So our omega is minus 6, then minus k cross x naught I plus y naught j. This should be equal to minus of Vt, which is 1.4. Let me just omit the units because we know everything is in meters per second. So 1.4 I plus 1 j. Okay, so k cross I is, so minus and minus will get cancelled. They both will become, basically this will be a positive quantity, 6k. Then k cross I is j. So this tells us that 6x naught equals the j component, which is 1, So x naught will be 1 over 6. And similarly, if we look at the second component, k cross j, this is minus I. So minus 6 y naught. This is the x component because k cross j is minus I. And this will be just 1.4. This is the I component on this side. So y naught will be minus 1.4 divided by 6. What are the units of these numbers? So this is in meters per second. This is in meters per second. So yeah, so actually we should remember that we are using omega r here, but we should have just used omega. And the value of omega was minus 10 meters per second because the radius was 600 millimeter. So if you look at the previous problem, we had figured out the value of omega. So rather than using 6 here, we will use 10, and the units will be meters. So sorry, this unit is radians per second. So radians per second. So per second and per second cancel because these are all in meters per second. And your final answers will be in meters. So this 6 will be replaced by 10. This 6 will be replaced by 10. So we can report everything in millimeters for easier, nicer reading. So 1 by 10 meters, 1.4 minus 1.4 by 10 meters. In millimeters, this will become 100 millimeters. And this will become 0.14 meter, which will be 140 millimeters minus. So the position vector where velocity is 0 is 100 millimeter minus 140 millimeters. Now, an important part, how I figured out my mistake was basically I was trying to check my units, and units of x and y should be in distance. So when I got 1 over 6 and I realized that I was using meters per second, which was canceling out, I realized that there was a mistake in the number. And rather than using omega r, which I used initially, which was 6 meters per second, I should have used omega, which was minus 10 radians per second, not meters per second, so that I get the units correct. So this is how you can figure out your mistakes as well and avoid these in exams and while solving problems. So always take care of your units. Thank you. And if you have any confusion on how we got VT, please check the previous problem where we have solved VT.